I know you've been wondering, well, what about if it's not a plate? Perhaps we have a hollow metal conducting sphere. Or even if the sphere itself is solid, if it's conducting, we know that the charges end up on the outside of the sphere and they distribute themselves evenly because they don't like each other. So if we look at them, the charges themselves are going to distribute themselves evenly all over the entire surfaces. All right, so the question is, what is the electric field inside this hollow sphere? So if we take a look, we know that anything that we place in here, if we have our positive test charge here, 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 wherever we place that positive test charge, what happens to the forces actually inside the sphere? And we've looked at this before. The forces inside any conducting sphere are going to be zero, so the electric field strength also is zero. So anywhere we place our positive test charge isn't going to end up being negated, so anywhere we go, the net force on it is actually going to be zero. So we can conclude inside a hollow sphere or a solid conducting sphere, the electric field is going to be 0 newtons per coulomb on the inside. There is no electric field inside metal conducting spheres, and really any object, solid object at all. Now, let's take a look on the outside. If I were to take my positive test charge and place it over here, what would happen on the outside? Well, if we look here, a positive and a positive, these are going to repel. So we have a line that comes out like so. If I place the test charge down here, I'm looking here, we end up this, goes like this, goes like this, like this. So we end up with a very, very similar situation that we had when we actually had a point charge. So we have this radial thing with a hole in the center where there is no electric field on the inside, but it's almost like the object itself is a point charge where they're radiating outward. So if we look, if we take a proton or we take any other particle and put it on the outside right here, can we go back and then figure out what the electric field strength is using 1 over 4 pi EL Q2? Who is Q2? Yeah, it's the thing making the field. The big one, Q2, is the object that's creating the field itself. And then divided by r squared. So this formula is good, very good, as long as you're on the outside of the sphere. All right, now, what happens when I take this particle and I move it on the inside of the sphere? All of a sudden the formula fails and we end up, there is no electric field on the inside, there are no forces acting on the object, so we're back in this like black hole of sorts of electric field. So the formula is great up until you reach the surface of the thing, and then once you go inside, the formula itself is negated and no good.